Today is January 17th, 2023. This is my 196th episode for C++ 17 2023 CUDA SQL OpenGL OpenCL DBB Vulkan. This is 26th episode for vector calculus, 9th episode for line integrals. In this episode, I will discuss center of mass, moment over inertia over wire. We will solve three problems from Thomas's Calculus 13th edition, chapter 16.1, line integrals, page 954. Copy from Thomas's Calculus 13th edition, page 954. In this page, you can find Table 16.1 Mass and Moments formula for coil springs, wires, and thin rods lying along a smooth curve C in space. I implemented all these things in my calculus library. If you want to follow my current and future session, you need updated C++ library extensions. If you double-click it, you can download updated C++ library extensions. I assume you have watched my previous videos listed here. Without further ado, let's get started. Open up Visual Studio Code. CPG 17 2023 parallel. Select empty space. Click this button. 196. Moments. Click this button. Moments.cpp. Hit enter. Ctrl B. I will remove this file. Ctrl plus. From this PDF, if you scroll up, you can find example 4 in page 553. I will arrange side by side. We need to include CPG, CPG, SED, extensions, .hpp, include CPG, CPG, calculus, namespace, CNA, CPG, numerical analysis, namespace, CPT, CPG, types. I will copy and paste this. Thomas's Calculus 13th edition, chapter 16.1, line integrals, page 953. 953. Example 4. Example 4. We are going to solve example 4 as in figure 16.4. Figure 16.4. Void test line integral moments of wire. Example 4. Int main. Copy this function name. Paste it here. We need using namespace, CPG, operators, and constants. We have to represent half unit circle on YZ plane. In this figure, this half unit circle lies on YZ plane. CNA, BC, TR, 3D, R, semicolon. This half circle lies on YZ plane. X component is 0. So X component is 0. Y component is return SED cosine T. This is Y component. This T represents angle between Y-axis and a point on this curve from the origin. This angle between y-axis and this radius represent t. Copy, paste. This is z component, sin t. Remove trailing comma. This r represent this unit circle, y square z square 1. In this case, t is greater than or equal to 0, less than or equal to t. The angle runs from 0 to pi. Now we have to know the density. The density is represented with this formula. This represents density. Or density CPT make tuple. This is function. Sorry, we don't need this. We can create lambda or x or y or z semicolon return 2 minus z. The value of z comes from this component. The value of x comes from this component. The value of y comes from this component, respectively. Now, or math. We can use r line integral. We pass density. Or mass answer. The value of mass computed algebraically is computed here. This is 2 times pi. Now SED, C out, math. I say numerical computation result. This is numerical computation result. Is we have to pass the boundary of t or interval of t 0.05 CPG and there. Copy, paste. This is algebraic answer like this. We will test if it builds successfully. I will open Clang compiler. CD 196 moments Clang SED C++ 20 moments.cpp ltb 12 oc.exe. Hit enter. CLSC. So our numerical computation and the algebraic computation matches. Now here or CM. This is center of mass. R center of mass. We have to pass density. SED C out center of mass. We call CM by passing 0.05 CPG and there. We build again. CLSC. So this is our center of mass. In case of x coordinate, it is 0 because it lies. This curve lies on YZ plane. Its center of mass. X coordinate of center of mass is 0. Also, y coordinates of center of mass is 0. In case of z coordinates, this is the value. If we double check, this is the answer. So we can say for center of mass nth is 8 minus pi over 4 times pi minus 4 semicolon. We can say this is numerical computation result. We can pass here, copy. I will just say correct answer. We can say this value here. I missed one parenthesis. We build again. CLSC. So our computation is very, very accurate. Now, rho I are moments of inertia. We pass density. We can say moments of inertia. I here. We build again. CLSC. This is moments of inertia. If you scroll down in exercise 16.1, if you scroll down in the arch in example 4, find Ix for the arch in example 4. This is problem 41. We want to find Ix. Okay. The answer of this problem is, if you scroll down, you can find from this book. This is 16.1. Scroll down, chapter 16. I will copy this, add new bookmark, save. Problem 41. This is the answer. This is 2 pi. This value matches mass answer. Okay, this is exactly mass. So if we examine, this is Ix. Moments of inertia with respect to x-axis is the same with this value as in this answer. So we solved all problems. Mass, center of mass, moments of inertia. Now let's move on. Page 955. Hit enter. From exercise 16.1, scroll down. We find mass and moments. We will solve problem 33. I will zoom up. Void test line integral problem 33, mass of wire. Copy this function, paste it here, disable it here using namespace CPG, operators and constants. In this problem, find the mass of a wire that lies along the curve. This curve is given. Copy, paste. This is t square 2 times t. T is greater than or equal to 0, less than or equal to 1. This is our density 3 over 2 t. So this is our problem. CNA, BCTR, 3D, R, x component is 0. So 0.0 x component. Then this is y component. Or t, return, copy, and paste. We can do like this. Remove this parenthesis, comma, copy, paste. 2t is here. Remove trailing comma. So this is Y component. This is G component. Don't miss semicolon. We define this curve here. Now we define density function like this. Or density, or this is a function of t. Return 3.0 over 2.0 times t, semicolon. Please compare this problem with this one. In this case, density function takes three parameters x, y, z. In this case, our density function takes parameter t. Now, oral, math, numerical computation result. We use this position vector r, then line integral. We pass density. This function returns a function. Once again, this line integral function returns a function. We can directly pass the value of t. We can pass the value of t, for example, 0.0, 1.0, because this function returns a function. We can call like this. Now, our answer is 2 times square root 2 minus 1. Check out the answer sheet. Now, SED, see out, we can say mass of the wire, mass NCR, CPG, and there. Copy, paste. Correct answer. We can simply pass answer. Now, with this, we copy this function and pasted it in the function main. Y is equal 65. Okay, it's resolved. We can use Microsoft compiler. CL, EHSC, SED, C++ training, moments.cpp, fe, m.exe, hit enter. CLSM. Our numerical result is correct. We will now solve problem 35. Paste it here. Void test 35. Mass of wire with variable density. Copy this function name. Copy Ctrl N. Paste it in the function main. Disable it. As always, using namespace, CPG, operators, and constants. This is our curve. Pasted it here. This is square root 2 times t I square root 2 times tj 4 minus square t. So this is our curve. T is defined in this interval greater than or equal to 0, less than or equal to 1. CNA, VCTR, 3D, R, semicolon, or T, return this value here, comma. We can use square root 2. Copy, paste this y component. Copy, paste 4 minus t square. Here we can say t square. Remove trailing comma. We defined curve R. Now we have two density. Or density A or T return 3 times T. Copy, paste. This is density A. This is density B. Or density B 1. This is wrong. It should be floating point. Or mass A R Y is squiggle. Let's try it. Line integral density A. It returns function. We pass 0.0, 1.0 because copy, paste. But this is default, so we don't need this because this is default interval. Copy, paste. Mass B, density B. Or answer A 4 times square root 2 minus 2. Or answer B square root 2 plus LCD log 1 plus square root 2. These are the answer. Check out the answer sheet. LCD, C out, mass A, CPG, and there. Copy, paste. Answer A, copy, paste. Copy, paste. I will make it and L and L. This is mass B, answer B. Mass B, answer B. Now, in the command prompt again, we rebuild CLSM. Perfect solution.